Okay, let's graph y equals 2 to the power of x using a table of values. I'm going to choose x values from -3 to 3 and sub them in. So just remember, with a negative exponent, it's the reciprocal, and then the power is positive. Anything to the power of 0 is 1, and then 2 to the power of 1, 2, and 3 are fairly normal. And we'll plot these points. Okay, when graphing the y values an eighth, a quarter, a half, just do your best and kind of estimate where they are. Once we get to 0, 1, etc., it's pretty easy. Now I can kind of see the pattern, so I kept it going a little farther. Okay, so I kind of see on the right that it went 2, 4, 8, and then I just kept it going, went 16 as well. If I want to go to the left, we could do the same. So what's important now, though, is if we kept going to the left and kept on putting in more negative x values, it would always be 1 over, but then something bigger. So it's going a half, a quarter, an eighth, then it would go 1/16, 1/32, 1/64, 1 over 128, 1 over 256. It just keeps on getting smaller and smaller and smaller as you go to the left, but it's never going to equal 0. It'll always be 1 divided by some large number. It'll also never become negative. So what happens is that the x-axis is actually a horizontal asymptote as we head to the left for this exponential function. So as you go to the left, we just usually think that it's just going to follow. As you go to the right, it increases incredibly rapidly. So it's going 1, 2, 4, 8, 16, 32, 64, 128, 256, etc., etc. The domain of this is all real numbers. We can put absolutely any number up into an exponent. The range is y is greater than 0. This is our basic graph. Anytime we graph anything that has a base that's greater than 1, it always has this basic shape where it comes in along the x-axis. From the left, it's on the x-axis, then it goes through 0, 1, and it increases rapidly as we get past the y-axis. So it doesn't matter if the base is 2, 3, 4, 5, 6, anything bigger than 1 always has this basic shape. Now we're going to shift gears and we're going to graph something that has a base between 0 and 1. So we're going to graph a half and see what happens. I'm going to use the exact same table of values, but what happens with the negative exponents is that now, because it's a half, it flips and becomes 2 to the power of. And then when you get down to the positive ones, that's when you're going to get the reciprocals. So everything just kind of flips. So when we graph these points, what we're going to see is that this is actually a half to the power of x is really just a reflection of 2 to the power of x in the y-axis. So it's kind of nice to notice that this is just a reflection, and towards the end I'll show you why algebraically. The graph's exactly the same, except for the only difference is as you go to the right, the x-axis is a horizontal asymptote. As you go to the left, when the base is between 0 and 1, it increases rapidly. What I always remember is if I'm trying to figure out which way does it increase, is it increasing to the left or to the right, just go whatever your base is to the power of 1. If I go 2 to the power of 1, it's 2. Okay, if it's bigger than 1, then I know it's increasing as I go to the right. If I go a half to the power of 1, it stays a half, so it must be decreasing as I go to the right, but it never goes across the x-axis, and the x-axis is an asymptote. The domain and range of y equals a half to the power of x is exactly the same as the domain and range for y equals 2 to the power of x. And now we'll talk about the fact that this red graph is a reflection of the blue graph through the y-axis. So what we have to remember from functions is that a reflection through the y-axis is y equals f of negative x. So that means I just make my x negative, so it becomes 2 to the power of negative x. Well, we can actually separate that. So this is the same as 2 to the power of negative 1 to the power of x, because when you raise a power to a power, you multiply the exponents. Well, 2 to the negative 1 is a half. So anytime you have 1 over 2, 1 over 3, it doesn't matter, 1 over anything, it's always that base 3, but then reflected through the y-axis is what that negative is telling me. So this red graph is our basic graph. Anytime a base is between 0 and 1, it always increases to the left. So it follows the asymptote to the right, but it increases as you go to the left.